Thank you. Well, thank you all. Yes, indeed, I do have all those years of experience, and I also have an excellent plastic surgeon, by the way, who spends a lot of time on me. I'd like to recognize my co-author, Ali Zera. Ali, please stand up. He's with the Arizona Department of Transportation and provided a lot of the background material you see here. I was previously with the Arizona Department of Transportation for about 35 years, and it's a great state. Maybe not quite as great as California because we don't have an ocean, but who knows? Stay tuned. You never can tell. I wanted to I wanted to make a little comment about this morning's presentation. My good friend and partner, George Souza, talked about his 4 very beautiful assistants, Katia, Carla, Susanna, and Rosanna. Boy, those are nice names, aren't they? But I want to mention that they are all engineers. They are all civil engineers, and I know they're very good at their job. So I thought it would be nice to recognize them. I don't know if they're in the audience or not, because it's not an easy thing for a woman to be an engineer. It's not easy for a man to be an engineer, to be perfectly honest, but if they're here or not, I think you should give them a little applause, because I think that's quite a great accomplishment. Yes. Okay, we're going to move on, and Sergi's going to prompt me here when I go over. They only allowed me 20 minutes. I normally take 20 hours, but that's okay. I'll spare you that today. You've already heard a lot about this man, Charles McDonald, and I had the good pleasure of knowing Charlie. He's long gone now, too bad. He was a real pioneer, a real true pioneer. And it's true, he did develop this material just to fix up the roadways in the Phoenix area, just temporarily. Back in those days, middle 60s, roads in Phoenix were really not in too good a shape. And thanks to him, a lot of roads in Arizona are in very good shape today. So sometimes one person can make a difference. Oftentimes nowadays we do things by committees. We have to have 47 committees do everything, but sometimes it just takes one person to make a big change in the world. And I applaud Charlie McDonald for doing that and having the perseverance and personality to do it as well. Charlie always had a smile on his face. He was always in a good mood. Even when people were asking him lots of questions and saying things couldn't work, it didn't seem to bother him. He seemed to believe they would work in the long run, and sometimes that's what you have to have. You have to have that knowledge in your own mind that something is going to work and just keep on going. And that's the way my colleague George Souza is. George doesn't smile as much as Charlie did, but I tell you, he does have that enthusiasm to get things done and to keep going. He doesn't give up. He didn't give up on this conference, and I know for a fact he could have given up many, many times, but he didn't. And so, like I say, just one person can make quite a difference in the world. In the early days, things were pretty primitive. Equipment was very primitive. It was kind of like, make it in your backyard and see what happens. And there were a lot of failures, a few successes, but a lot of failures in the early going. Eventually, they got better at what they were doing, not a lot better, but a little better. And even though in those days they did a lot of manual labor as far as getting the rubber into the trucks in order to spray the rubber, nevertheless, it was progress, and again, some good things happened along the way. So what happened along the way? Well, for one thing, they came up with a seal coat process, which was called a SAM, stress-absorbing membrane. And the thing about asphalt rubber is because of its high viscosity at high temperature, you can put down a very thick layer of this material before you put the chips down. And we found that would prevent the reflective cracks very well. So this was the first really practical application of this material, and it came about in the early 1970s. And to get to this point, they had to burn up a few boot trucks along the way, but they eventually got to it. And then later, through some other additional research, they found that an interlayer, a stress-absorbing membrane interlayer, would also work very well. And in fact, many of the early projects in Arizona were this type of construction. They were a 2-phase type construction, place a seal coat, and then place an overlay on top of it. And this is still a very good process. It's not terribly popular in Arizona today, primarily because we'd like to do everything in one process. We'd like to avoid having to do things twice, simply because we have a lot of traffic in Arizona, just like you have an enormous amount of traffic in California. For those of you who hadn't noticed, just drive around California for a while, and you'll notice that I used to say everybody in California owned 2 cars and they drove them at exactly the same time, which is really amazing, But I think it's true. There's a lot of vehicles. The only place I found more vehicles than California is China. And that's an amazing place, too. And I know George eventually will talk about that. Some of the early seal coat jobs were focused on really, really badly cracked highways. They were seal coating them as a temporary action, only to last a year or two until they get around to overlaying them. The way funding went in Arizona, sometimes that would take more like 5 or 6 or 8 or 10 years. So it turned out we learned a lot from these early seal coat jobs about the ability of asphalt rubber to retard reflective cracking. And cracking, indeed, is why this material was eventually adopted in Arizona, was to prevent reflective cracks. In other words, when you overlaid a pavement of this bad a nature, you could prevent the cracks, or at least delay them for a very long time from coming through. Raveling is another issue. Fortunately, we don't see much of this in Arizona anymore, but many years ago, the Federal Highway Administration, and I think wisely so, promoted the use of open graded friction courses as a safety means of getting us safer highways. And a lot of states tried this. Arizona and California had used them for many years. But one of the problems with the open graded friction courses is that they do tend to ravel. And the reason for that is because you can't really put too much asphalt into an open graded friction course. At least you can't if you use regular asphalt, because it all runs off, and then you have a bleeding situation. So you're always between either raveling or bleeding. So you'll see later that the adoption of asphalt rubber for open graded friction courses really has prevented this from occurring. Arizona is not just Phoenix, Arizona, although we always thought of that way as a desert. About half of our state is actually mountainous. It has snow, has ice, has cold weather. People have to chain up their vehicles to get up to Flagstaff, Arizona, or Show Low, and sometimes we even have to shut down the highway because there's so much snow. I know you won't believe me, but it is the truth, and it is very well documented. So let's talk a little bit about the product that we use in Arizona, which is not terribly different than California, but a little different. First of all, we just use crumb rubber made from waste tires, and those are usually U.S. passenger tires. And Arizona generates about roughly 5 million tires a year, thereabouts, and that's a lot of crumb rubber. So there's an ample supply of it. And then the material is mixed in a mixer, and in fact, this particular control unit, which you see at the front of the device there, is actually in front of this in the veranda area. And it's not a terribly complicated piece of equipment. It's highly computerized and does a wonderful job of intimately mixing the asphalt and the rubber. And as someone said today, that process of mixing the two and creating a kind of a gel material is what gives asphalt rubber its unique property of having a high viscosity at a high temperature. It's roughly about 20% ground tire rubber and 80% asphalt. And normally in Arizona, we use about 1 or 2 grades softer asphalt than would be normally used for the PG grading. So in Phoenix, PG grade in Phoenix is about a 70-10 or 76-10 or 76-16. We use a 64-16 for the base asphalt for asphalt rubber in Phoenix. And in Flagstaff, they typically use at a high cold temperature area. We use about a 58-22. And those work very well as the base asphalts. When you add the rubber to it, it becomes a somewhat stiffer asphalt at high temperatures. So that's good for rutting, preventing rutting, and it also gives you some good cold temperature properties as well. The mixing is a little bit complicated, but not too complicated. A little bit of piping, a little bit of plumbing, a little bit of pumping, and a whole lot of heat. And then eventually you can pave with a normal paving operation. These are the gradations of the open graded and what we call gap graded or coarse graded material. You'll notice that the gradation for the, if I get this pointer to work here, if I can see it. Here it is. Whoops, that doesn't work so good, does it? Do you have one here? Okay, we'll go back. Like this right here. Watch it, gentlemen, so I don't take your eye out. That's not very bright. Oh, there we are. You notice this grading here, which is the gap graded or coarse graded, very much like an SMA type gradation, and you can see the 2.36 or number 8's down around 20-some%, which is like an SMA, just don't have very high 200s. And then the open graded is pretty much a one-size chip. You'll see a picture of that a little later on. These are kind of what the surfaces look like. As we all know, dense graded is indeed pretty dense sometimes. That's why people put seal coats and other types of surfaces over them, because if they're just left by themselves, they tend to be very, very slick and polished. Gap graded, more like an SMA, and then the open graded, almost all pretty much one size stone, sort of like a seal coat with a lot of asphalt. Cracking experience in Arizona, this is why this material has really been so widely used in Arizona, is because it does reduce the cracking. So as you can see, over a long period of time, once you get up to, this is roughly about 10% cracking, you get up to about 10% cracking after about 10 or 12 years. Now the road's in pretty poor shape, whereas if you use asphalt rubber, even out here at 17 years, it's still very small amounts cracking. You don't see much in the way of fatigue cracking. All you do see some. This is an example project we did in Flagstaff back in 1990, and see this is an old, badly cracked up concrete pavement. We overlaid it with asphalt rubber, and after a number of years, it performed very well. This is an example test section we did on that same project. And you can see here we had 100 millimeters or 4-inch overlay over that concrete. After 8 years service, very badly cracked. This we had half the thickness, only 50 millimeters, the asphalt rubber mix, and very few cracks after that same period of time. Same roadway, same environment. This is in the mountains, so this does get snow in the wintertime. Maintenance costs, another reason why we've seen this material used widely in Arizona. Other states, it's much less than conventional mixes. And again, this is due to the fact that there's just much less cracking to have to maintain. Rut depth, pretty good. It doesn't rut to a great degree, and that's again because you have a lot of stone-to-stone contact. And then you have skid numbers, mu-meter numbers, skid numbers also are quite good. Normally because, again, of that surface coarse texture, the material is a good texture, a good drainage layer. And again, because with the dense graded, you have to come back, do maintenance, and oftentimes that means putting more oil on the roadway. Smoothness has been very good over the years. This is inches per mile, which is probably many of you in the audience are more familiar with that than millimeters per kilometer. And you can see that oftentimes in Arizona we have projects that start somewhere around 40 inches per mile by ROI, or even sometimes even less. And you can see the rubber sections do quite well over time. Splash and spray, this is something that was talked about in this morning's session with regard to safety. The people in Texas have done some work on this, as have the people in California. And I believe, from what Doug Carlson told me, there is a report available, I think, in your black packet that describes the work in Texas with regard to reducing spray and reducing accidents. And recently, California Highway Patrol published a similar study. I don't know if that's in the packet or not, where they found a similar reduction in accidents. And why is that? Well, it's because the splash and spray is reduced, and that's better visibility. And we have a video of that. And if I'm real lucky, this video is going to work for 1 minute. So we're going to find out. This is the acid test. So we'll see what happens.
Go right after this stuff.
Okay, go ahead.
Okay.
This is a road in Texas, and these are people with the Texas DOT, and they're videoing and following a truck. This is on a dense surface of asphalted concrete. And they're going to come up to a section that has an open graded surface, and when that happens, you'll see it's quite dramatic. What he's trying to do now is catch up to that truck, so he's kind of in that spray envelope here. This is the sort of thing you would encounter in a lot of states in the U.S. Probably have a little more rain than Arizona, but certainly California and certainly many of the states back east or even in Texas.
Gee, this is perfect.
See that one of the problems here is it's hard to see the vehicles ahead. Sight distance is not good. And of course you're having to deal with that spray all the time. And of course the road is slick, which is not a good thing. So they come off of this bridge now. They're going to go on to the open graded surface. I think they actually call this a porous surface there rather than open graded. You can see how dramatic. Remember the same rainstorm, same traffic, same truck. Quite the change. And in their studies in San Antonio, where they placed a open graded friction course with rubber on top of concrete, they saw a dramatic reduction in accidents, I think on the order of 50%. And in fact, many lives were saved. I don't know the exact number, but several fatalities were saved as well. Besides the safety issue, there's also noise, which has been something that's come about here recently. And my colleague, Ali Zero, will talk about this on Friday. Extensive studies in Arizona and California have confirmed over and over again that the open grader with asphalt rubber is extremely quiet. And in fact, it's so quiet that the citizens of the Phoenix area have consistently wanted more and more of this material to be placed. And indeed, almost all of the concrete in the Phoenix area now is covered with this material. A little bit about costs and usage. You can see here that when the patents came off in 1992, the cost of a ton of binder. Arizona is a little bit unique. We bid the binder tonnage. We bid a ton of binder in our costs separately from the mix, for that matter. So most states combine the two, so you don't really know how much binders cost. But you can see here the cost per ton. It's gone up a little bit. In fact, in 2006, it went way up, even higher than this, because of the gasoline price of gasoline went up, and asphalt's sort of a byproduct of that. So that number 297 was considerably higher in the spring of this year. It's probably beginning to fall back down to earth now. This is a cost per square yard, or in this case, square meter per 25 millimeter thickness, which is like square yard per inch. And you can see it's a relatively expensive material. But on the other hand, it's typically placed in less thickness. As an example, in Arizona, the typical thickness of dense graded is approximately 5.5 inches, and the thickness of the gap graded is about 1.7 on average. Somebody give me some water there? A little bit of water. I want to go dry here. The air here is very dry, too, for that matter. They should really do something about that. Thank you. Okay, we're almost done. Notice also at the bottom the fatigue cracking. Dense graded mixes that we've seen over a number of years have like 20% fatigue cracking, and we've only seen about 2% fatigue cracking over all these years with asphalt rubber. It's a little bit hard to see, I know, but the point here is it's kind of a ghost or shadowy type figure here, but all those red things are roads covered with asphalt rubber in Arizona, in the Arizona DOT system since 1988. Roughly about 20,000 lane kilometers. That's used about 20 million tires, and about 45% of the ADOT system has been paved with asphalt rubber mixes. Just to recap the benefits, you've seen these already. Doesn't hurt to see them again. Less reflective cracking, maintenance more durable, less rattling, good skid resistance, smooth ride, good hot cold climate, less splash and spray, less noise, good engineering use of old tires, and cost effective. And, you know, we've come a long way. I think Charlie McDonald would be very, very happy and pleased to see how far we've come. So with that, I'll let you ask all those dangerous questions. Thank you.
Thank you, George. We have time for questions. If you have any questions, please raise your hand and we'll bring the mic to you. I know George does a wonderful job, but I'm sure you have a question somewhere there.
There's one way in the back.
Way in the back.
Way in the back. There's a man way back there.
Katian?
George, you mentioned that the base asphalt that you're using for the cold climate was 5828.
I believe it was 5822.
Is that polymer modified?
Not to my knowledge.
Okay, thank you.
I don't believe any of the asphalts in Arizona are specified to be polymer modified, and I don't believe any of them, I could be wrong, but I don't believe any of them have been in the past, unless we specifically called it out for a test section. There's one back here.
George, in your last slide, you mentioned that one of the advantages of asphalt rubber is less rut. Is it because of the aggregate structure or because of the binder?
Probably both, but I think probably more so the aggregate structure. Another colleague of mine, Dr. Kalush, has done some testing with these mixes using the Sharp, I guess they used to be called the simple performance tests. Maybe they're not so simple. I don't know what new name they're coming up with. But it turned out that if you did not confine these materials, they didn't look very good in rutting. Okay? But if you did confine them in the laboratory, they had tremendously high rut resistance. In fact, and I know Dr. Kalush could correct me, but I think one of the mixes was as high as he's ever tested of any mixes anywhere in the U.S. And I know ASU, Dr. Witzak, and Camille have tested a lot of mixes with the Sharp, what I guess I'm calling Sharp or SuperPave or the simple performance test protocols. And so this material, when it's confined in a thin layer, lots of aggregate to aggregate, rock-to-rock contact, has excellent rut resistance. And in fact, you know, we've seen like 100 miles or so of concrete freeways overlaid with 1 inch of the open graded. You really don't see any rutting in that material at all. I mean, there's virtually no rutting of any kind. A section on Interstate 10, for an experimental purpose, we placed 3 inches. This was about 10 years ago or so. 3 inches on top of a dense graded, 3 inches of the gap graded on Interstate 10 traffic, and again, virtually no rutting after 10 years of service. So you have a high amount of rock-to-rock contact here, and as long as that material is confined and the underlying layers are pretty stiff, rutting does not seem to be an issue.